Welcome to the PowerPoint slideshow. I am Ahmed, a first-year engineering student in York University, and today we will discuss a critical problem that exists in our world, which is climate change and global warming. What is climate change? Climate change is a long-term change in the average weather patterns that have to come to define Earth's local, regional, and global climates. These changes have a broad range of observed effects that are synonymous with the term. Since the pre-industrial period, human activities are estimated to have increased Earth's global average temperature by about 1 degree Celsius, a number that is currently increasing by 0.2 degrees Celsius per decade. So each 10 years, Earth's temperature increases by 1 degree Celsius. In 2016, as shown in the graph, Earth's increased 1 Celsius degree. Carbon dioxide and other substances are referred to as climate forces because they force or push the climate towards being warmer or cooler. They do this by affecting the flow of energy coming into and leaving the Earth's climate system. Small changes in the sun's energy that reaches the Earth can cause some climate change, but since the Industrial Revolution, adding greenhouse gases has been over 50 times more powerful than changes in the sun's radiance. The additional greenhouse gases in Earth's atmosphere have had a strong warming effect on Earth's climate. Future emissions of greenhouse gases, particularly carbon dioxide, will determine how much more climate warming occurs. Ice cores drawn from Greenland, Antarctica, and tropical mountain glaciers show that Earth's climate responds to changes in greenhouse gas levels. Ancient evidence can also be found in tree rings, ocean sediments, coral reefs, and layers of sedimentary rocks. This ancient or paleoclimate evidence reveals that current warming is occurring roughly 10 times faster than the average rate of Ice Age recovery warming. Carbon dioxide from human activity is increasing more than 250 times faster than it did from natural sources after the last Ice Age. There are three main ethical questions I'm going to tackle in this section. Will nuclear power cause more problem than it solves? Is CO2 capture and storage an acceptable option? Are improvements in technical efficiency just undermined by more consumption? The first one is the issue of whether to build new nuclear power stations as a way of tackling climate change is one of the most controversial areas. There are four basic problems with nuclear power: connection with nuclear weapons, disposal of radioactive waste, safety of nuclear installations, and cost. The current tensions over North Korea and Iran's nuclear plans, not to mention the possible theft from badly secured stores of Russian, demonstrate that these issues still have major international security implications. Is CO2 capture and storage an acceptable option? CO2 capture and storage raises a number of ethical issues. The first is whether the CO2 injected into the ground will leak out. Current research indicates that the CO2 will remain, but it is still a technology in the early stages of development. Are improvements in technical efficiency just undermined by more consumption? When energy efficiency is improved, it obviously leads to a drop in the amount of the energy that can be sold by suppliers. To compensate, which is the same for any business whose sales fall, the suppliers try to lower the price so that people are encouraged to consume more. Unfortunately, such a response can undermine the originally energy savings. The simplest way around this is for energy prices to be increased by the use of taxes. The particular taxation method of most relevance to climate change is carbon taxes, whereby the taxes is determined by the emissions of CO2 per joule of energy. Unfortunately, many large businesses involved in energy generation and use oppose such taxes because of the potential cost of their businesses. However, some businesses have more progressive environmental policies and supports such taxes.